Hello everyone. A very warm good morning to all of you. Dear authors and invited guests, welcome to the technical session 3B. Myself, Srushti Rokde, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the International Conference on Technological Intelligence and Business Strategies, TIBS 2026, Manila, Philippines. This conference is being organized in hybrid mode. The physical event was held yesterday in Manila, Philippines, and the virtual event is being held through Zoom from 23rd and 24th June 2026. I hope you will enjoy the knowledgeable and interactive session through the day. And in this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question answers. On the 10th minute, I will raise a gentle reminder for the presenters. And there is another request to all the participants that you all should stay connected with us till the closing remarks. And if you have any query or update, then you can write it to me in the chat box. Just before we can start our session, let me introduce our session chairs with you. So we have Dr. Mohammad Firoz Mrida. He is in Professor and Head, Department of Computer Science in American International University, Bangladesh. Dr. Mrida is a senior member in IEEE and is a professor and head in Dean Department of Computer Science at American International University, Bangladesh. He is founding director of Advanced Machine Learning Lab at BUBT. His research interest includes artificial intelligence, AI, machine learning, deep learning, and natural language processing. His research experience within both academia and industry results in over 120 journals and conference publications. Along with him, we have our second chair, Professor Uma Maheshwari, Assistant Professor at Jaipur Engineering College and Research Center, Jaipur, India. So, to introduce her, ma'am is an assistant professor in Department of Computer Science and Engineering at JECRC, Jaipur, Rajasthan, with 14 years of teaching experience and 2 years of technical expertise. Her skill set spans C, C++, Java, J2EE, .NET, and RPA technologies, with numerous certifications including machine learning and network security. She has published around 20 research papers, authored a book on operating system, and has 2 patients. So with this great start, I would like to call the first paper presenter on our screen. So to start with, let me call the first paper presenter of AI-based writing tools as intelligent decision support systems effect on academic performance, autonomy, and AI integration in higher education. Can we have Rovenia Sibayan from Oman to present her paper?
So, uh, good morning, good afternoon, everyone. Okay, in every part of the world who are here in our conference. So today we explore an important shift: how AI grammar checkers, how AI tools or writing tools are no longer just a grammar checkers, but also an intelligent decision support system that actively shape how students think and write. And our study examined how these tools influence the performance, the autonomy, and the which is also related to institutional practices in higher education. So I am Dr. Rowena Sibayan from Gulf College, together with my co-researcher, Dr. Hazel Tagalog, and Dr. Sally Domingo. Our research title is about AI-based writing tool as intelligence decision support systems. Okay, so let me guide you with the presentation outline roughly. So let me begin with the context, research question, conceptual framework, methodology, research design, key findings, the problem statement, research gap, risk and ethical challenges, practical and institutional implications, and the conclusions. Okay, so let's start with the context. Today, the AI writing tools are just I mean, it was embedded in our daily activities, whether you are a student, whether you are a searcher, you're an employee, or even if you are a business people. Okay. But let's focus on how this AI tool as intelligent decision support system shaping academic writing and learning behavior. We also focus on the key dimension, which is about learners' autonomy, the academic performance, and the institutional AI integration in higher education. The purpose also of our study is to move beyond the surface level improvement because let's face the reality that most of our students are using AI now most of them, without adding any critical analysis or reflection. So this is the focus of our research paper. Next, um, it says there that the AI-based writing tool as an intelligent decision support system, because we are going to study on how the context, okay? We are going to examine the AI tool as an intelligent support system shaping academic writing and learning behavior. We also be concerned on the genuine learning, okay, how this exists or no, the AI tool to foster true learning or only on the surface level writing improvements without cognitive engagement. And there are so many research out there, okay? But most of the study focus on the outcome, like how to improve the grades, rather than analyzing how the students interact with the AI feedback during the writing. And again, we will be focusing on the risk of the over-reliance of AI suggestion that can bypass essential cognitive processes like the synthesis, analysis, and the evaluation. The central focus of our questions, okay, is how just let me, I cannot see the screen. Okay. Examine how AI writing tools affect academic performance. Or we could say how AI, a writing tool, affect performance, autonomy in education, in higher education. We also focus on how this multiple dimension learning, okay, we need to emphasize of that signals the study and does not only treat learning, but also we have to treat them as a multi-dimension learning when it comes to performance, confidence, and autonomy. And also we will be focusing on the importance of autonomy and engagement, not only on how they are going to improve their marks when they are going or preparing their assessment or any type of academic works. This is the conceptual framework that we use during our research. Okay, so it says here that the intelligence, okay, the process is the AI will become an intelligent support wherein it analyzed the draft and shaping writing decisions beyond mere error correction. Let's face the reality that most of our students now are, when they use any type of AI writing tool, they just type whatever they want to do, and then the AI writing tool will provide the response according to what they have written. And many of them are just relying on what is showing on the screen. And so this is the outcome, okay? So this is our process. We input and then that's process. We have to find out the errors, and then we will be guiding them with the revision guidance, not only by looking, and then they have to build confidence when it's the output is of course not only to improve the grades or the marks, but also to reduce errors and to improve their confidence in writing. So this input process outputs are not, let's say we cannot implement it correctly without the involvement of the institutional layer. Okay, and that institutional layer includes the academic, okay, the governance, the institutional governance, and what they call that, the ethical integrations of how AI can be used in academic writing. The research design that we applied is the mixed method approach, wherein we use the convergent mixed method design, the quantitative and the qualitative uh, design. And then we have a 100 participants involved, the undergraduate students, with a 6-week intervention where the AI were integrated into their weekly writing. Okay. And then the data collection method. So we measure that with the pre and post assessment writing score with the collected insight through the survey and reflection. Of course, the rest the research ethic is also our concern in terms of their data privacy. So this approach allowed us to capture both the outcome and the students' experience. Now, the key findings of our research. Okay, so the key findings of our research is most of the students' outcome improves in terms of their mean assignment grades. It rose significantly from 68.5% to 73.2% after the AI tools, showing, of course, with the positive impact. It also increased student confidence in writing, attributing improvement on how this AI tool enhanced clarity in structure. Another key findings that we have found out is the rising of the AI tool usage. The daily use of AI writing tools increased sharply during the intervention, reflecting growing engagement and reliance. Of course, we have to understand also the cautious interpretation, the interpretation of their output, wherein the performance improvements are promising, but it requires caution as they do not capture all the learning nuances. Another findings that we have found out is about the autonomy, okay, and the engagement pattern. The autonomy and engage pattern, we found out that some of the students actively evaluate the AI feedback, choosing uh, which suggestion to accept or reject to enhance their learning, while some of other students or other students passively accept AI corrections without reflection, which may limit the true writing independence. And then the other key findings in terms of autonomy and engagement is the importance of pedagogical guidance. So effective teaching shapes on how students interact with AI feedback, promoting a genuine autonomy and engagement. So of course, it's not only the marks. Again, we also find out that this autonomy and engagement patterns as were observed during our intervention. And then the what are the risks, okay, and the ethical challenges during our research? We found out about the over reliance risk of our students. The excessive use of AI tools may limit critical thinking and independent problem solving skills. The data privacy concern, which also about their data and how it is protected when using the AI writing tools, is also a raising concern, ethical concern. The academic integrity issue is another risk and ethical challenges because the use of AI must be managed carefully to prevent breaches, academic honesty, and maintain fairness. So in our university, we have this kind of AI form declaration that we are implementing so that the students are aware on the consequences of what will happen when they rely only on the AI, the use of AI. Okay. And that is part also of the responsible use of AI. So we implement that in our university to highlight the importance, the guide on how the students will be guided with the use of AI in their classroom or any assessment activity. Now, in terms of how, because that our research is from the students to the process academic, to the educators, and to the institutional level. So we have some practical and institutional implications of how this AI are being utilized in our in higher education. One, the classroom strategies. So we should not only make an assessment that would ask the students to the writing tool that how to do this, okay, or what is this, what's the meaning of that. But educator should create a task that encourage students to reflect on and critically evaluate AI generated content for deeper learning. Also, to incorporate the ethical AI practices wherein or to integrate the use of AI and process-based assessment to promote responsible AI engagement among the students. The most important factor is the institutional policy. So clear policy on AI use when it comes to authorship, transparency, and data protection are very essential to guide the responsible use of AI integration. And of course, we cannot we cannot skip the staff training or the student training. So the comprehensive training programs for the staff and the students support effective and responsible AI adoption in higher education. Okay, so the the findings or the conclusions, okay, to conclude our research, the AI writing tool can significantly enhance performance, confidence, and efficiency in higher education. So this is our main findings of that. It's really enhanced their performance. Also, we found out that the limitations of AI in learning, wherein the AI benefits do not guarantee the deeper cognitive skills because of the over-reliance risk or the independent writing development in students. And then the important guidance of AI use, so effective use of AI use depends on pedagogical guidance and ethical oversight by education and institutions, and then responsible integration is essential for sustainable educational value and human judgment augmentation. Again, I will end my presentation with this quote: AI can augment human thinking rather than replacing it. Thank you and good afternoon.
Hello, ma'am. Am I audible?
Yes, ma'am.
Ma'am, my question is how can we check the authenticity of the content that is generated by the AI tool?
How can we check the
Authenticity of the content that is generated by the AI tool.
Yeah, actually, that is one of the very challenging part of the educators now when we are trying to find the authenticity. And as me as an educator, that's one thing. So first, during the process, so we gave them the scenario or the assessment, and then we allow them to use the AI writing tool. Now, when they submit us the assessment, it's not only the submission, but we have to find out, we have a consistent rubrics also that will be implemented. We have to find out, okay, that it is really the writing of the student, it is really the students who wrote that, or it's merely coming from the system. So our institutions are implementing different types of methodology. So of course we have the what you call that, the similarity check that is being implemented institutional wise. And then we have also implementing the academic judgments based on the performance, the weekly or the performance of every student. That's why we have to find the to know if the students are really engaged in terms of their writing. So we implement the AI. We have the policy of how they will use the AI tool, and that if that will be if they violate that, so students know that they are facing some consequences. So most of the students avoided that kind of incidents. So again, we have the tools, we have the rubrics, and we have the academic judgment that being implemented.
Thank you, ma'am.
So if there aren't any other questions, we would like to move forward with the next presentation. Thank you, ma'am.
Thank you.
So the next paper we have is Bi-level PSO LP Framework for Carbon-Aware Business Optimization by Somini Devi Viramanchaneni in India. Ma'am, can you please share your screen?
Good afternoon, everyone. This is Soumini, working as Assistant Professor at Mahindra University, Hyderabad, India. Today, I am going to present my work titled A Bi-level PSO-LP Framework for Carbon-Aware Business Optimization. What motivates to do this work is, if we particularly see in the business, the modern businesses must balance both the profit and environmental sustainability. So if you take the traditional supply chain optimization, it primarily focuses on either minimizing cost or minimizing carbon emission. And these carbon emissions are becoming increasingly important due to regulations and sustainability goals. So selecting an appropriate trade-off between both profit and emission remains challenging still. So our goal is to develop an optimization framework that automatically selects the best balance between both the profit and emissions. So, and the organizations are facing increasing pressure due to improve profitability and also to reduce a carbon footprint due to environmental conditions and to meet the sustainability regulations and also to maintain the efficiency. So how can any company or any business strategy automatically determine the right balance between both profit and emission without manually tuning any carbon penalties? Is it that we don't have any solutions? As we have some solutions, we are having a linear programming optimizer, which provides optimal and feasible solutions, but it requires manual tuning of carbon penalty parameters. Similarly, we are having PSO, particle swarm optimization, one can use in order to get stronger global search capability, but it may generate infeasible solutions. So the existing approach do not automatically learn the trade-off between both profit and emissions, and while also maintaining the feasibility. So both LP or PSO alone may not achieve our both profit and emission conditions. So in our work, we have the following are the fivefold the contributions. First, we are trying to formulate the carbon-aware supply chain optimization as a bi-level problem. And then we have developed a hybrid PSO-LP framework. We are combining basically both PSO and linear programming. Then we are automatically trying to optimize the carbon penalty parameter lambda. What is this lambda? We will see. And we try to ensure the feasible and optimal operation decision through linear programming. We have validated our algorithm on both synthetic and real-world datasets. Coming to the first one, the problem formulation, we can see our objective is to minimize the cost. C of x is a cost and E of x is the emission. Both together is to be minimized. This lambda is a parameter which is to be found without manual tuning. That's what our goal is. So the challenge lies in selecting the appropriate value of lambda. So how can we automatically learn the best value of lambda? And we have to minimize this objective while maintaining the constraints. What does our bi-level optimization framework means? At the upper level, we are trying to use PSO, particle swarm optimizer, which try to search for the best possible or optimal parameter lambda possible value. And then once we find the best lambda, then we are trying to solve using that particular lambda, we are trying to apply the LP solver, which try to compute the optimal shipment plan for the selected lambda. And the lambda we are getting from PSO. So this is a flow. Once we are using PSO to select the lambda, then with this lambda, we are trying to apply LP and to get the optimal shipment plan so that both profit and emissions are getting maintained. We are trying to maximize our profit and minimize the carbon emission. And this is the workflow. We try to initialize the PSO swarm with set of candidate lambda values, then solve the LP for each of the candidate lambda, and then try to compute both profit and carbon emissions and evaluate how the quality is the solution. Then we try to update the particle positions and velocities, and we repeat this process until we converge. The solution converges and return the optimal lambda and also the optimal shipment plan. Coming to the experimental setup, we have evaluated our algorithm on both synthetic data sets and also the real data set. And what metrics we have used is the profit, emissions, how good it is at convergence, and how robust is the method. The baselines is only LP, how good it is performing, and only PSO versus our hybrid PSO plus LP. On the synthetic data set, if we see only LP when lambda equal to 0, we can see the corresponding profit is some 1983 units and the emission is 416. When lambda is 0.5 with only LP solver, we are getting 1957 and the emission is 348 units and so on. Whereas our method, that is hybrid PSO LP, is giving, we can see something 1957 and emission is some 348. If you are saying the optimal parameter is found around lambda equal to 0.7, that we can see through a graph, and the hybrid PSO LP is achieving strong profit and emission balance. It is not only that we are not seeing only the maximum profit or minimum emission. The trade-off between both we are trying to see. And no manual parameter tuning is required. PSO automatically selects the best lambda. You can see here the mean fitness between hybrid PSO LP and standalone PSO. Our hybrid PSO LP is getting 1783 and almost in whatever we are running, there is no deviation. We are getting the same value, whereas PSO is getting the standard deviation of 381. This is the Pareto trade-off on synthetic data set, that is emission versus profit. If you see here, each point corresponds to different lambda value, and the lambda equal to 0.7, we thought of it is, we can see here, when lambda is 0, you are getting the maximum profit, that is 1980. And also when lambda equal to 2 point something, you are getting minimum emission. But our goal is not to minimize emission or maximize profit. We want to achieve both. So the trade-off, the best is getting it lambda equal to 0.7, which is given by our PSO. Coming to the convergence, this x-axis shows the number of iterations and the fitness is shown on y-axis. We can see the blue line is with PSO, standalone PSO, whereas red one is our method, that is hybrid. You can see our hybrid is having the best fitness. It is almost convergence at every iteration. It converges very rapidly. If you see the lambda versus profit and emission, the blue one here is the profit and the orange one is emission. When the lambda is increasing, both are almost stabilized. So increasing lambda lowers our emissions and profit also is getting reduced. So the best is around lambda equal to 0.7, somewhere here, where the profit is maximized and emission is minimized. In the same algorithm, our method we have run on real data set, on real supply chain data set. This is the Pareto trade-off shown here, and the convergence is shown here. Similarly, the comparisons is shown here. If you see here, the robustness, that is mean fitness, is not given here on the real data set because our real data set exhibits very narrow profit emission trade-off and the hybrid framework converges within, if you see here, in 2 iterations, it is getting converges. So indicating that it's having a very stable and well behaved optimization landscape. So robustness, measuring robustness is not really required. Coming to the key findings, the hybrid PSO LP automatically learns optimal carbon penalty parameter lambda. It also guarantees the feasible operational decisions while PSO performs global search. In our synthetic data set, it exhibits a strong profit emission trade-off and it achieves stable convergence with 0 variance across the runs. Whereas with standalone PSO, we are getting a standard deviation of some 380 something. And on real-world dataset, it shows a weaker trade-off due to cost-emission correlation, and of course, no manual parameter of lambda is required in our method. Coming to the conclusion, we proposed a bi-level PSO LP framework, which automatically selects the carbon emission parameter. It tries to combine the PSO, the exploration property of PSO with LP, linear programming exact optimization property. It automatically balances the profitability and sustainability goals. It tries to demonstrate the robust performance as we have seen in our graphs. And coming to the future work, we want to try this on non-linear emission models and also to try with uncertainty-aware optimization and to extend to the multi-objective functions. And we want to try it on large-scale supply chains. How does it impact the business? So of course, it supports sustainable supply chain decision making, and it automatically balances the profitability and environmental objectives. It tries to reduce the dependence on manual parameter tuning, which is really a challenging situation. And it's applicable to logistics, transportation, and green supply chain management. And it provides a scalable framework for carbon-aware optimization. Thank you. If any questions are there, I'm happy to answer.
Why you considered a linear way
Sorry?
for calculating the carbon emission? Why you considered the linear way instead of taking non-linear?
No, this problem, this algorithms are applicable on any linear programming problems. With
Okay.
alone a linear programming problems, we are not able to solve everything like both profit and emission.
And what are the parameters you are considering for this?
Which one, ma'am?
What are the different parameters you are considering for this?
In the sense, our parameter is only one, that is lambda.
That only. Why you are considering sir only lambda?
So you can see if the first objective is, or the first part in the objective function is cost, transportation cost from shipment I to shipment J. Whereas the second component is emission, the carbon emission when you are actually transporting from I to J. So our goal is, see, if you are taking only C, it has to be maximized, of course, because it's a profit. If you are taking E, it has to be minimized. The emission should be
minimum,
reduced.
right?
So
Yeah.
we are trying to combine both of these. When lambda is 0, it is only we are maximizing the cost. But we are not taking care about emission. But here our goal is in order to achieve both profit and reduce the emission. So we are combining both with some parameter lambda, and this lambda is unknown. When we are manually trying with different possibilities, yes, we can try, but that will take more time. Our PSO, because PSO tried to search the entire space with some starting from a swarm of particles. So initially some few set of lambdas will be scattered in the solution space and try to search from particular lambda and try to return the best lambda. In the next iteration, it tries to update using its personal best and global best and again return the best lambda. So lambda is only parameter, I would say.
Okay. Okay, ma'am. That's all from my side.
Thank you. Can
Thank
you
you,
stop
ma'am.
sharing?
Yes, sure. Thank you, ma'am. So moving on to the next presentation. So next paper we have is customer experience with robot vetter services, the role of trust in technology and perceived enjoyment in driving revisit intentions. So the presenter is Chelsea Calista Limanley. Do we have her in the meeting?
Yes, so thank you for the introduction. Allow me to share my screen. Good afternoon, everyone. First of all, I want to say thank you to TIBS 2026 for the opportunity. And I would like to introduce my teammate, Finka Valenia and Ihwan Masadi, and also myself, Chelsea Kalisalimanlim. We are from Binus University Hotel Management Program. Today, we will present our research title called Customer Experience with Robot Waiter Service, the Role of Trust and Technology and Perceived Enjoyment in Driving Revisit Intention. Let's start from the background first. So AI is rapidly transforming the hospitality industry, and many restaurants now use robot waiters to improve efficiency and create unique dining experience. While this service can be entertaining and innovative, some customer may still feel hesitant about AI-based service. Therefore, this study examines how trust in technology and perceived enjoyment influence the customer intention to revisit restaurant using robot waiters. Right, moving on to literature review. So, based on the technology acceptance model, we use 5 variables. There are perceived usefulness is about how robot waiters improve their service quality and efficiency. Second one, we have perceived ease of use is about how easy the system is to use. Third one, we have the trust in technology is about confidence in the reliability and safety of the technology. Fourth one, we have perceived enjoyment. It's about the fun and satisfaction gained from the customer experience. Last one, we have intention to revisit. It's about customer willingness to return. So we propose that both functional and emotional factors influence the revisit intention. So this is our conceptual model. So based on the literature review, we create the conceptual model as you can see from the screen. So we use hypothesis 1 is perceived usefulness favorably affect the intention to revisit. Hypothesis 2 is perceived usefulness favorably affect perceived enjoyment. Hypothesis 3, perceived ease of use favorably affect the intention to revisit. Hypothesis 4, its perceived ease of use favorably affect perceived enjoyment. Hypothesis 5 is trust in technology favorably affect the intention to revisit. Hypothesis 6 is trust in technology favorably affect the perceived enjoyment. Hypothesis 7, perceived enjoyment favorably affect the intention to revisit. Hypothesis 8 is perceived enjoyment serves as the mediator in relationship between perceived usefulness and intention to revisit. Hypothesis 9, perceived enjoyment serves as a mediator in the relationship between perceived ease of use and intention to revisit. Hypothesis 10, perceived enjoyment serves as a mediator in the relationship between trust in technology and intention to revisit. Moving on to methodology. So this research, we use a quantitative approach based on the technology acceptance model. So the data were collected through an online survey from 180 respondents aged from 17 and above who had experienced the robot waiter service. All variables were measured using 5-point Likert scale and analyzed using SAMPLS. Moving on to result. So a total of 180 respondents participate in the study. Most respondents were female aged from 17 to 24 years old, and mostly they are students. And they most visited restaurant 3 times per month and held a bachelor degree. And this is our path coefficients table. So as you can see, the hypothesis 1 is not supported because the p-value is 0.106, which is higher than 0.05. So this means that perceived usefulness does not have significant direct effect on intention to revisit. Although the relationship is positive, but the effect is not strong enough statistically. So, and 9 out of 10 hypotheses were supported, like perceived usefulness did not directly affect to intention to revisit, but it significantly influenced the perceived enjoyment. And perceived ease of use and trust in technology both positively affect to the perceived enjoyment and intention to revisit. And perceived enjoyment also had a significant positive effect on customer intention to revisit based on our coefficient table. Moving on to discussion. So for the discussion, we found that 9 out of 10 hypotheses were supported. Second one, we have perceived usefulness did not significantly affect the intention to revisit. So hypothesis 1 was not supported. Third one is perceived usefulness significantly influenced the perceived enjoyment. Number 4, perceived ease of use has a positive effect on both perceived enjoyment and intention to revisit. Number 5 is trust in technology had a positive effect on both perceived enjoyment and intention to revisit. 6, we have perceived enjoyment significantly influenced the customer intention to revisit. Last one is perceived enjoyment successfully mediated the relationship between perceived usefulness, perceived ease of use, and trust in technology and intention to revisit. Moving on to conclusion. So, trust in technology and perceived enjoyment are the strongest factors driving the revisit intention. So, our customer value enjoyable experience more than functional benefits alone when interacting with the robot service waiters. And moving on to recommendation. First one, we have to, well, perhaps we can improve the robot waiter's reliability to build a customer trust. And number 2, we can use the robot waiters together with human staff to maintain a service quality. Number 3, we can make a robot interaction more enjoyable, friendly, and more engaging with the customer. Number 4, provide a clear instruction for customer, especially for the first-time user. Number 5, we can train our employees to operate and handle the robot waiter system properly. Number 6, we can collect our customer feedbacks regularly to improve the service experience. And number 7, we can use the robot waiters as a support tools, but not as full as replacement for the human service. And this is for the limitation. So we limited sample size with 180 respondents and only included customer with prior robot experience. For the future research, we can use a larger and more diverse sample to improve the generalizability of the findings, and we can include additional variables such as technology anxiety, social presence, and novelty effect. And also we can apply longitudinal methods to better understand our customer acceptance of robot waiter service over time. So that's all about our presentation. Thank you for your attention. We are happy to answer any question.
My question is, what is the basic purpose of taking the age group of 17 to 24?
Would you please repeat your question, ma'am?
What is the purpose of taking the age group between 17 and 24 as your
Certainly,
respondents?
certainly, miss. So allow me to discuss it with my teammate first. I will get back to you shortly. Allow me to answer your question, ma'am. Yes. So because the age from 17 to 24 is suitable for our study research, because since they are usually more familiar with digital technology, so we feel it's more open to trying a new dining experience. And they are more interested in modern restaurant concepts such as robot waiter service.
What specific features of robot waiters you are considering compared to human waiters?
Yeah. Allow me to write down your question. Could you please repeat once again, Miss?
What specific features of robots you are considering as robot waiters compared to human waiters?
So the so the robot features that we're focused are is more reliability, ease of use, and consistently, and also efficiency and enjoyment. So robot waiters can support a simple tasks such as like food delivery. So they can make more consistently and more efficiently, while the human staff are still trying to needed for the personal interaction and handling more complex customer needs.
Actually, my question was what human feature is overcome by robot waiters? It's okay, ma'am. Thank you.
All right, thank you very much for your question, ma'am.
Thank you, ma'am. So moving on to the next presentation. So we have a paper, enhancing customer experience through human-centered AI in self-ordering restaurant systems by Brandon Octavianus. Do we have him in the meeting?
Yes.
Yes, sure. So please present your screen.
All right. Allow me to share my screen. All right. Is my screen visible right now?
This visible.
All right. Thank you for the introduction. Good afternoon, everyone. First of all, I would like to thank TIBS 2026 for this opportunity. Allow me to introduce myself. My name is Brennan Octavianus, and today I will be presenting my collaborative research with Charles Jonathan, Julia Cristina, and Ijuan Masnadi. We are from Nusantara University, from the Department of Hotel Management. And the title of our collaborative research is Enhancing Customer Experience Through Human-Centered AI in Self-Ordering Restaurant Systems. Moving on to introduction. The introduction of this research, the hospitality industry has experienced rapid growth in the adoption of AI-enabled technologies, especially in restaurant services. One example is self-ordering technology, which has changed the way customers interact with restaurants. Self-ordering kiosks and digital ordering systems are introduced to improve convenience and operational efficiency by allowing customers to place their own orders, reducing waiting time, and have more control over their ordering process. However, customers today do not only expect technology to work efficiently, they also expect fast service, easy interaction, and a seamless experience when using these systems. Therefore, the concept of human-centered AI becomes important. Instead of focusing only on technological capabilities, human-centered AI focuses on designing intelligent service systems that prioritize customer needs and improve their overall customer experience. This research aims to understand how customers perceive and accept self-ordering restaurant technology through factors that influence their attitude towards using these systems. Moving on is our research objectives. We have three main research objectives. which are examine the impact of technology readiness on customer attitude, analyzing mediating roles as perceived ease of use, perceived usefulness, and perceived speed, and also understanding how human-centered AI enhances customer experience. Right after that is our literature review. Our main model is using technology acceptance model, or in short, TAM. TAM was discovered by Fred Davis at 1989, and TAM explains user acceptance toward technology. So, moving on is our what is the definition of self-ordering restaurant technology? Self-ordering technology enables a consumer to place their own order from their table to computers. And finally is our technology acceptance variable. To understand customers' acceptance towards self-ordering technology, this research focused on 5 main variables, which are technology readiness, perceived ease of use, perceived usefulness, perceived speed, and attitude towards using. Based on our literature review, we developed this conceptual model and these 10 hypotheses. The hypothesis 1 is technology readiness has a positive effect on perceived ease of use. Hypothesis 2 is technology readiness has a positive effect on perceived usefulness. Number 3 is technology readiness has a positive effect on perceived speed. Number 4 is perceived ease of use has positive effect on attitude towards using. Number 5 is perceived usefulness has a positive effect on attitude towards using. Number 6 is perceived speed has a positive effect on attitude towards using. Number 7 is technology readiness has a positive effect on attitude towards using. Number 8 is perceived ease of use mediates technology readiness and attitude towards using. Number 9 is perceived usefulness mediates technology readiness and attitude towards using. And finally, hypothesis 10 is perceived speed mediating technology readiness and attitude towards using. Up next is our research methodology. The only method we use is quantitative explanatory research with a cross-sectional survey of 200 respondents in the Jabotabek area. Jabotabek area is 4 areas. There is Jakarta, Bogor, Tangerang, and Bekasi, which are in the island of Java in Indonesia. Respondents experience using self-ordering systems. And the analysis tool that we use is SEMPLS, or partial least squares structural equation modeling. Up next is our respondent profile with 57% female and 43% male. There is 94.5% of the age 17 to 25, with 5% of 26 to 35 and 0.5% of 36 to 45 age group. And then for the occupation is 63% student and 29.5% employee. Based on the table value, our factor loading, Chromebox alpha, composite reliability is above 0.7, and our AVE is above 0.5, which means all conduct are valid and reliable. And for our findings, as you can see in this path coefficient table, our p-values shouldn't be over 0.05 to be supported. Hence, our hypothesis 1, 2, 3, 4, 6, 8, and 10 are supported, whilst our hypothesis 5, 7, and 9 are not supported. Up next is our discussion. We have 2 main discussions that we are gonna talk about. technology readiness impact customer beliefs about self-ordering technology by positively predicting perceived ease of use, perceived usefulness, and perceived speed, validating the hypothesized impact of parasuramans. And also, customer value their efficiency and time performance over functional benefit when using self-ordering systems, reinforcing prior research emphasizing time-saving advantages in restaurant technologies. These are our conclusions. Technology readiness indirects affects customers' attitude. Perceived speed is the strongest determinant, and human-centered AI should prioritize a fast service whilst being easy for interaction and also having seamless customer experience. Our recommendations for the research is improving kiosk responsiveness, simplifying interface designs, reduce wasting time, and enhancing customer-centered AI interactions. And these are our limitations for our research. It was dominated by young respondents and being only focused in Jabotabek area, which again is Jakarta, Bogor, Tangerang, and Bekasi. If we have a future research, these are gonna be our main research ideas. It will be in a different age group, could be different countries or could be different areas in Indonesia, and also additional variables such as trust, enjoyment, and service quality. Thank you for listening to our presentation. If there is any questions, we would be happy to answer.
Actually, my question is, though your system completely is determined based on customer feedback, as a developer, what factors I can consider or you can consider to improve the values of hypotheses that have not been supported?
All right, thank you, ma'am, for your question. I will be answering that question in a few moments. Kindly wait. Okay, I would like to answer your question, ma'am. Um, for from a developer's perspective, what we could improve are for perceived usefulness. Developers can add more features that provide clear benefits for customers, such as personalized recommendations, an easier menu navigation, or accurate order customization and loyalty integration. Also, payment convenience. These could improve and help customers recognize practical values of the system. For technology readiness, developers can focus on making the system more accessible for different types of users by creating a more intuitive interface, providing clear instructions, and ensuring the system is reliable and easy to understand. This can increase customers' confidence and willingness to use the technology. By improving these aspects, future research may find stronger relationships between these variables and customers' attitude towards self-ordering technology itself. Is my answer enough for your question?
Yeah, but for specific hypotheses, in between 2 to 3 hypotheses are not supported. For that, what could be the specific answer?
All right, ma'am. I'll get back to you with that question. So for the three not supported hypotheses, uh based on our findings from our questionnaires and our um research, customers find that when they are using it, that it is not as useful as human interaction. So, as the recommendation of a developer, we should put the system AI by using navigation and giving guideline and tutorial for the interaction with the machine or kiosks.
Okay, sir. Thank you.
Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
So, moving on to the next presentation, we have a paper titled as Extending the Technology Acceptance Model in Quick Commerce Mobile Applications, the Role of Interface Usability and Trust, and presented by Agnes Gracia Hosiana. Ma'am, can you present your screen?
Yes. Can you see my screen?
Yes, ma'am, it's visible.
Okay. Good afternoon, everyone. Today I will present a study entitled Extending the Technology Acceptance Model in Quick Commerce Mobile Application, the Role of Interface Usability and Trust. The research aimed to investigate the factor influencing user behavior intention to use the Astro Quick Commerce mobile application by extending the technology acceptance model with two additional variables, interface usability and trust. This presentation consists of 7 main sections: the research background, problem statement, literature review, research methodology, result, discussion of the result, and finally the conclusion and recommendation. The mobile commerce has become a key component of the digital economy, enabling transaction anytime and anywhere. Quick commerce emerges as a speed-driven digital retail model, delivering daily necessities within minutes via mobile application. Unlike conventional e-commerce, quick commerce demands seamless navigation, secure transaction, and reliable service fulfillment. Platform success depends on operational efficiency as well as user evaluation of interface quality and platform credibility. For this reason, Astro was selected as the research object because it represents a quick commerce platform where user experience and trust are critical for adoption. This research was conducted because there are several important research gaps. First, the traditional technology acceptance model mainly focused on two beliefs: perceived ease of use and perceived usefulness. However, in quick commerce environment, users also evaluate the quality of the application interface and the trustworthiness of the platform. And most previous studies have focused on traditional e-commerce or general online marketplace. Research specifically examining quick commerce application remains limited. Third, empirical studies that integrate both interface usability and trust into them within the quick commerce context are still scarce. And this study extends them to better explain user adoption behavior in quick commerce application. This study addressed three main research questions. First, how does interface usability influence perceived ease of use and perceived usefulness? Second, how does trust influence user attitude toward using and behavior intention? Third, do the original time relationship remain valid in the quick commerce context? Based on this question, the objective of this study are to examine the influence of interface usability and trust, test the time relationship, and propose an extended time model specifically for quick commerce application. The theoretical foundation of this study is the technology acceptance model developed by Davis in 1989.
This study proposed 8 hypotheses. H1 and H2 examined the influence of interface usability on perceived ease of use and perceived usefulness. H3 examined the relationship between perceived ease of use and perceived usefulness. H4 and H5 examined the influence of perceived ease of use and perceived usefulness on attitude toward using. H6 and H7 investigate the effect on trust on attitude toward using and behavioral intention. And finally, H8 examine the influence of attitude toward using on behavioral intention. All hypotheses are expected to have positive relationship. This study employed a quantitative research approach using an online survey. A total of 258 valid responses were collected from active users of the Astro mobile application. The research model included 6 constructs. Data analysis was conducted using PLS SEM, and this method was chosen because it is suitable for predictive research and allows simultaneous evaluation of both measurement and structural models. The significance of the hypothesis was tested using bootstrapping with 5,000 resamples. And from the respondent profile, the characteristics indicate that the respondents were generally young and digitally familiar users, which is consistent with the target market of quick commerce application. The first stage of analysis focused on assessing reliability on convergent validity. All constructs achieve Cronbach alpha, Rho A, and composite reliability value above the recommendation threshold of 0.70, and all average variance extracted or AVA values exceeded 0.50. These results indicate that all measurement items are reliable and valid for further analysis. The structural model demonstrates very strong explanatory power. The R-square value range from 0.934 to 55, indicate that the model explains a very high proportion of variance in dependent variable. Furthermore, all 8 hypotheses were supported and statistically significant. The strongest relationship was H1, where interface usability significantly influenced perceived ease of use, with a coefficient of 0.967. The findings indicate that interface usability is the strongest predictor in the model. A user-friendly interface significantly improves users' perception that the application is easy to use. Good interface design also increases the perceived usefulness of the application because users can search for products, place order, and complete payment more efficiently. In quick commerce environment where speed and convenience are essential, interface usability plays a critical role in shaping user experience. The result also revealed that trust is the strongest direct predictor of behavioral intention. Users who believe that Astro is secure, reliable, and capable of protecting their personal information are more likely to continue using the application. Trust not only influence behavioral intention directly, but also contribute positively to user attitude toward the platform. This finding suggests that building user trust is essential for sustaining long-term adoption in quick commerce service. There are 5 main conclusions from this study. First, all 8 hypotheses were supported. Second, interface usability is the strongest predictor of perceived ease of use. Third, trust is the strongest predictor of behavioral intention. Fourth, the model demonstrates very high explanatory power. And finally, user adoption in quick commerce is influenced not only by a functional belief, such as usefulness and ease of use, but also interface quality and trust in the platform. And based on the findings, several practical recommendations can be proposed. Quick commerce developers should focus on improving interface usability through intuitive design, efficient navigation, and simplified transaction process. They should also strengthen trust by ensuring secure payment system, protecting user privacy, and providing reliable delivery service. For further research, additional variables such as perceived risk, service quality, social influence, and price sensitivity could be incorporated. Research may also apply the model to other quick commerce platforms and use longitudinal research design to examine changes in user perception over time. And thank you for your attention. I hope this presentation provides some valuable insight. If you have any question, please feel free to ask.
Actually, can you tell me which is the current e-commerce application of this particular model?
Sorry, can you repeat the question again?
Can you mention the application in which this model has been applied currently?
Okay, please wait a minute.
Just my apologies. As a presenter, I shouldn't say this. But in a conference, how can people search and find answers? If they doesn't know, they have to just say don't know or something. Ma'am, you can take a call on that as a session fair.
Sorry, so the question is why we choose the Astro application?
Yeah. And why
Oh,
it is taking for you this much time to answer the question?
okay, so
Since
we
you have
select,
presented the thing, you would be expecting the questions, right?
yes.
Why you are taking this much time to answer the question? Why we need to repeat the question also?
I'm sorry for that. So we selected Astro because it is one of the leading quick commerce platform in Indonesia and also offering a rapid delivery service through a mobile application. And since quick commerce emphasize speed, convenience, and reliability, Astro provide an appropriate context for examining technology acceptance, interface usability, and also trust.
Okay.
So thank you, ma'am. Moving on to the next presentation. We have improving sarcasm detection stability using biphasic differential learning rates by Tanvi Pawar from India. Tanvi, are you in the meeting?
Yes, ma'am. Am I audible?
Yes, you are. You can present your screen.
Okay. Is my screen visible?
Yes,
Hello.
visible.
Yes, it's visible.
Okay. So, hello, good afternoon, everyone. My name is Tanvi Pawar. I'm from Pune Institute of Computer Technology and in IT Information Technology Department. So, the title of my research paper is Improving Sarcasm Detection Stability Using Biphasic Differential Learning Rates. So, I will first explain the problem statement and motivation. So consider this sentence, oh great, another Monday, just what I needed. The words sound positive, but the speaker is clearly frustrated. A sentiment analysis would classify this as a positive, and that is the problem. In our work, we found the specific reasons why sarcasm detection fails. The first is loss meaning without the context. The second is training instability. That training becomes unstable early on. And the third is fine tuning causes the model to forget what it already knows. So our paper addresses all these. So I will explain what are the existing approaches and the research gap. Now the field has progressed through a few clear stages. Early methods use SVM and word count features. They were fast but couldn't model context at all. Then CNN and bidirectional LSTM improved things but had no pretend knowledge. After that, BERT was a big step, but standard BERT fine-tuning still had some problems. It caused catastrophic forgetting and ignored social signals like subreddit identity or post scores in the Reddit comments. So no prior work combined metadata fusion with a structured two-stage training strategy. That's the gap we are feeling. So our system has three stages. The first is we the first is pre-processing and fusion. In
Tanvi,
that,
excuse me, can you make it in presentation mode in slideshow? Thank you.
so our system has three stages. The first is pre-processing and fusion. We clean the data and prepare the input, including metadata directly into the text. The second stage is the model, our robota as a backbone with a custom classifier on top. And the third is training and inference, our two-phase strategy with different learning rate for different parts. So we use SARC dataset, the self-annotated Reddit corpus dataset. It has over 1 million comments. The labeling is done by Reddit users themselves. When someone posts a sarcastic comment, they often add the S tag. That S tag denotes that the comment is sarcastic. The dataset creator scrapped these comments, removed the tag, and used it as a label. This means the labels are mostly correct, but not perfect. Some sarcastic comments were never tagged. That's the label noise, and I will come back to it later on. We used around 5 lakh comments, balance 50-50, 50% for sarcastic and 50% non-sarcastic, split 80% trend, 10% validation, and 10% test. I will explain the data pre-processing part. In that, first is text cleaning. We removed URL, usernames, markdown formatting, and HTML. None of this help in sarcasm. These are just the text cleaning part. The next is row filtering. Comments that were too short or too noisy that were removed. And the third most important is metadata fusion. Instead of building a separate component for subreddit and score, we just write them as a text at the start of the input. The transformer reads it like any other sentence. So this is our model methodology. The model has two parts. First, the backbone is our robot base. A transformer is pre-trained on 160 gigabytes of text, 12 attention heads, and 150 million parameters. It reads the full input and produces a single 768 dimensional vector representing the whole sentence. The vector goes into our classification head, which was designed by us. In that, two blocks of linear projection, normalization, and activation, and then a final output layer with two values, sarcastic or not. Now the training part. This is the core of the paper. When you first attach a new classifier to Roberta, it's randomly initialized. If you immediately unfreeze all 125 million parameters and train everything at once, Then the loss stayed at 0.693. That's what a model looks like when it just guessing randomly. It learned nothing. So we split training into two phases. The first phase is freeze the backbone completely. Only train the classifier head in that three epochs. The stabilizer, this stabilizes the head before we touch anything else. Then the second phase is unfreeze everything, but the backbone get a very small learning rate. That is 1 to the power 1 into 10 to the power minus 5, and the head gets 5 into 10 to the power minus 5. The backbone already knows the language, we just nudge it gently. So this is our training setup. We train on RTX 3090, used FP16 precision to save memory. Batch size of 32, Adam W optimizer training took about 3.8 hours for 11 epochs total. We used macro F1 as the main metric and not the accuracy. Macro F1 averages the score for each rows separately. So if the model is biased toward one class, macro F1 shows it, whereas accuracy might not. So result analysis. The final accuracy is 68%, macro F1 of 0.6854. The more interesting story is in the training curve. During phase 1, that is frozen back one, accuracy sat around 57%. The head was limited by what it could learn from fixed embeddings. Then in the fourth epoch, we unfreeze the backbone and accuracy jumped from 57 to 64. That jump is the biphasic strategy working. After that, the accuracy improved steadily every epoch until the epoch 9. Now, let's move on to the confusion matrix. So, 1 minute. So, in the confusion matrix, we got 16,856 true positive, 16,636 correct sarcastic ones, and the false positives are 7,333 and false negatives are 8,167. These two numbers are nearly equal. That matters because of the label noise I mentioned earlier. If the model had absorbed that noise, it would strongly avoid predicting sarcastic. We did see a much higher false negative count. The near equal split tells us that the model learned real patterns and not a shortcut. Okay. So advantages are the model trained stably across all 11 epochs. Metadata fusion added social context without any extra model complexity, and the balanced confusion matrix confirm no class bias. But there are some limitations. The biggest one is the model has no factual knowledge. If someone says, "Great, the Titanic sank exactly as planned," you need to know it was an accident to catch the sarcasm. The model can't do that. So that is the main limitation. And also there are some other limitations that poor cross-domain generalization, high computational cost, and it does not support multilingual. So these are our future. We can do this in a future work. So in the conclusion, we achieved 68.36 accuracy balanced on 500,000 sample SARC dataset with stable monotonic convergence and near symmetric misclassification rates. We solved the three problems that were not detecting the sarcasm. So I will like to thank the TIBS conference to give me the opportunity to present the work, and also my co-authors.
Tanvi, my question is, what about the data set you have used?
Yes, ma'am. I have used the SARC dataset. In that dataset, on
You
the
haven't given the details of the data set you have used.
okay, ma'am. I have used the SARC dataset. It is based on the Reddit comments. So dataset is extracted by it is a self-annotated Reddit corpus dataset. Means on Reddit there is a culture that users put the S tag on the sarcastic comments. So the developers or creators extracted the comments and scrapped that tag, and then created a dataset. By that S tag, they know whether it is a sarcastic or not. Hello, ma'am.
Okay,
Did
thank you.
I answer the question? Okay, ma'am. Thank you, ma'am, for the question.
Thank you, Tanvi.
Thank
So,
you, ma'am.
moving on, the next paper we have is Learning Management Systems and Academic Achievement, the Role of System Features and Demographic Moderators in Higher Education by Augustus Abbey. Do we have him in the meeting? Augustus Abbey.
Yes, please.
Yes, can you share your screen?
Yes, please. Good afternoon. I'm Augustus Abbey from Ghana. I'm presenting on the topic Learning Management System and Academic Achievement, the role of system features and demographic moderators in higher education. So the COVID-19 pandemic has had a significant effect on education, forcing many schools and universities to move to online learning. LMS had been used in education for many years, but its use has increased dramatically since the start of the pandemic, of which University of Education, Winneba in Ghana, was not left out. This learning management system helps students to have access to course materials on the platform for their studies, and that helps in enhancing their digital content engagement. So despite the widespread use of this platform, student learning experience and academic outcomes can be explained by the system features uh, this system has and their demographic characteristics. So this study is underpinned by two theories, which is the technological acceptance model that focuses on the usefulness and easy to use, and also explain learners' perception and adoption of LMS. And the second is the social learning theory that focuses on interaction and collaboration and explain learning through observation and interaction on forums. So the role for this study is to want to investigate the specific element functionalities that contribute to student academic performance and demographic and learner-related factors that moderate LMS usage and learning outcomes. So you want to know the various specific features that LMS has and how it helps in student performance. And again, to demographic factors that will also moderate the use of the LMS. And as a result of using, how does it help in the academic achievement? So reason for the study, this is the main picture. It says, why do some students thrive with LMS while others also struggle? LMS is central to higher education, but not all students benefit equally. So there is an issue here. So you wanted to know which LMS features actually matters for academic performance and how do student demographics shape LMS effectiveness. So these are design, state design with quantitative method, a cross-sectional survey, student of 381 students at the University of Education, Winnipeg. It was structured questionnaire. Um, our data analysis software that use was SPSS version 27, and our instruments were very reliable with a higher combat alpha. So our results, this is grouped into two key components. The one is personal and socioeconomic factors, which includes socioeconomic balance, factors, that the mode of delivery, mechanism, communication, interaction, and navigation usability. LMS usage and performance, that's still on the results. There is a clear positive relation. Yeah, so that means when LMS usage increase, performance also increase. The regression results, this is the most important part of our statistics here. It explained that 36.2% of variance in academic achievement is a result of the usage of LMS. So this means that out of 100%, 36.2% is being the results, or is being it being the results from which student uses LMS, and the other percentage, which is about 64%, will be other factors such as student study habit or teacher quality and others. And the next one is when students are using LMS, there is an increase. Anytime they use LMS, there is an increase of 0.5 units. So anytime student uses, you want to know how progressive LMS students have as a result of using it, the progress of it. So anytime they uses it, there is a 0.5 unit increase in LMS. So more LMS engagement, better academic performance is being achieved here. So the real life example for the data, students with higher LMS students with higher LMS use tended to one, access content more regularly. So the more they use the content, the platform, their performance tend to increase. Participating in discussion forums, when students participate in discussion forums, they acquire knowledge from their peers, and that also contributes to their performance. Use of interactive quizzes and progress tracking when a student knows his or her performances, it helps them to also work harder to improve because there is a tracking of their performances. But the barrier still remains on older students and those with lower proficiency and socioeconomic uh, poor backgrounds. So recommendations for universities and LMS designers, one should provide multilingual support. That means they should add other languages, especially schools that enroll international students so that to help in understanding whatever that is going on the platform. Students should accommodate different learning styles on the platform and should ensure offline and low bandwidth option. For instance, if a tutor want to upload um, some content on the platform, should try to minimize the size or compress the size so that with lower bandwidth, you can even have access to download and read more. And also training should be tailored on age and digital uh, literacy and should involve students in LMS design. Because when students are included in designing the LMS, they'll really understand by the situation whereby it's always coming from the policies makers, it makes it a bit difficult. So it's better students are also involved in the design. Still on the recommendation, says what institution also can do is to train educators on LMS features, to train them very well how to use it more effectively, the various features, and also understand the demographic characteristics that involve both the student and even the educators themselves. Also, to improve navigation and accessibility, which is very key. Students should be able to navigate, go through the platform very well, and accessibility, wherever that they are, there should not be any barrier. Even away from the school premises, they should have access. And also tech issues should be faced quickly whenever there is an issue and protect student privacy, which is very key, especially at their results, and create culture inclusive content. And as I said earlier, if students help design the LMS with their views, why wouldn't they use it? They'll really use it because they were part in creating and they'll have more interest in it too. So the limitation, a single university in Ghana was used and self-reported data by learners and could capture long-term usage pattern. So these are some free take-home message. LMS can boost learning as our results prove that there is a positive correlation. And technology alone isn't enough. You must teach system design. You must match system design to rare student diversity, what students really want, though it can't be measured. Both students and educators need to develop skills to use the learning management system to its full potentials. Thank you.
Other
Please,
than
any questions?
other than student community, can this model help out any common people?
Please, I can come again. I can hear you.
Other than student community, can this model help out any other people?
Please, can you come again?
Instead of student community, can this
Okay.
model help out any local common people also for learning any things?
Okay, it can because of the model that you use for social learning models. So when there is these platforms are more interactive, where students are able to collaborate. There is an interactions there. So for instance, let's take a platform like these social media platforms like Telegram and co. and even WhatsApp. People form groups, and in these groups, it's set as a platform for them for discussion. So it's not only for higher education, it also extends to other local communities. So when there is a platform where people can gather and share ideas, learning also take place. The activities there are also very key because the platforms enable them to come together and share ideas. And this is really seen in many social media platforms such as the WhatsApp, Telegram groups, and so many. Thank you.
Okay, thank you.
Thank you. Thank you so much, sir. Let's move on to the next presentation. So the next paper we have is Scalable Supply Chain Optimization via Feature-Aware Clustering by Somini Devi Veeramachan. Ma'am, can you please share your screen?
Hope my screen is visible.
Yes, ma'am, visible.
Yes. So good afternoon, everyone. I'm Saumani, working as assistant professor at Mahindra University, Hyderabad. And I'm going to present now the work titled Scalable Supply Chain Optimization via Feature-Aware Clustering. Just what motivated us to do this is again, our goal is to balance between the profit and carbon emission. The traditional linear programming problems solvers provides, of course, optimal solutions for either the profit or emission. And when the number of suppliers and demands or destinations are getting increased, the LP problems cannot solve more efficiently. The scalability will be a challenging issue. So solving full LP models becomes computationally expensive when the number of suppliers and demands increases or destinations increases. So our goal is to reduce, in this work, the goal is to reduce the computational complexity while preserving the solution quality. So it is like we want to obtain the near optimal solution, if not the exact optimal solution, but to reduce the problem size. So can we reduce the problem size while still maintaining the near optimal profit and emission performance? So coming to the research gap, the LP offers optimal solutions, but of course it struggles with the scalability as the size increases, the problem size increases. And the traditional aggregation methods, if we use it, they lose the structural information, and the naive clustering often degrades the quality of the solution. And the existing methods rarely preserve both the cost and emission structures. So we need to a scalable reduction framework that preserves both cost and emission. So our contribution is again a fivefold. In the first, we are trying to provide a clustering-based problem reduction framework in order to reduce our problem. And then feature-aware supplier and destination clustering. What type of clustering is used is basically on features rather than directly on suppliers or destination nodes. So by this, we are able to preserve the cost and emission profiles. And of course, we are getting a significant runtime reduction, which I'll show in the experiments. And we have performed the ablation analysis on the number of clusters. Coming to the problem formulation, the objective function is to minimize the aggregated sum of both profit or cost and emission. The Xij here is the shipment from I to J, supply I to destination J. And also, in addition to minimize this objective, we have to satisfy some constraints that the demand should be satisfied, and the total supply should be less than the whatever it is available, and each shipment should be non-negative. The challenge here is when the number of ij as they are increasing, The large-scale supply chain networks leads to very large optimization problems, so that the direct LP solutions will be computationally expensive. So why clustering? If we take the original problem containing of m supplier nodes and n destination nodes, the complexity becomes big O of m into n. The number of variables will be m by n. Whereas in clustering, if we are saying we are clustering from m to ks number of clusters, from n to kd number of clusters in the destination, so our number of variables are reducing to ks times kd. And where this case, that is number of clusters on supply, is very much less than the existing number of suppliers, that is m. Similarly with kd. Hence optimization becomes very significantly smaller. So why feature-aware clustering? Why not directly clustering on the direct nodes? Yes, the traditional clustering may ignore optimization relevant information, that it will not take the entire CIs and EIs into consideration. So, but what we are considering is a feature-aware clustering. For example, if you take the supplier feature vector, it looks something like from supplier I to whatever destinations it is going J, that is, those all costs will be taken into consideration. That's what this CI1 and so on CIN. Similarly, emission EI1 and so on to EIN. This is our vector, the feature vector we'll consider. Just for a numeric example, if from supplier S1, if it is going to, let's suppose 12, 15, 8, 10 can be, it is going to 4 destinations with one CI1 as 12, C21 as 15, and so on. Similarly, this 5, 6, 3, 4 are emissions. This is a feature vector we are considering. On these vectors, we are trying to do clustering. This is for one supplier. There will be these vectors for m number of suppliers, similarly for n number of destinations. Our key idea is suppliers with similar transportation costs and similar emission patterns will try to merge as a cluster. The benefit we get from this clustering is it tries to preserve both economic and environmental clustering, and also resulting in higher optimization fidelity after clustering. This is a workflow. First, we are going to take both cost and emission matrices available with us. Then we are trying to construct the feature vectors from this and try to normalize the feature vectors and apply any type of clustering we can apply. We have applied the k-means clustering, which is simple and effective. And then we'll get the clustered supply chain. And on this, we can apply the LP. So this is how our objective function looks after applying clustering. Instead of Cij, we can see here C bar KL, that is the number of supplies and demands got reduced to K and L instead of Ij. For example, on the real data set, which we are having, I have mentioned in the footnote, the real data set, the supply chain shipment data set, we are actually having 88 supply nodes and 43 destination or demand nodes. So in total, we are getting the number of possible shipments are 3,784. That is the decision variables which we have to find. But after clustering, if we are taking, let's suppose 5 as in the both supplier and destination clusters, so we are leading up to only 25 decision variables. So you can see the reduction achieves is almost 99.34% reduction in the number of variables. Why this 5? Just to show, but of course in ablation studies, I'll show that 5 is giving the better trade-off between accuracy and computational efficiency. So the dataset which we considered is supply chain data shipment dataset, which contains 10,324 shipment records, of which there are 88 supply nodes and 43 demand nodes. So the methods which we are going to show the results is what if we directly apply LP on the original supply chain, and what happens if clustered LP is applied, or LP is applied on clustered supply chain. And these are the 4 metrics which we are measuring on based on profit, based on emissions, runtime, and what is a gap between the original and clustered LP among these metrics. If you can see on this original data set, if you are applying directly on the original data set, the LP framework, then we are getting a profit of some X minus, that is minus 4.47 into 10 power 13. And similarly, some emission of some 1.98 into 10 power 13. And if you see the runtime in seconds, it is 0.0097. After doing clustering, and if you are applying LP on the clustered framework, we can see the profit is minus 4.75 into 10 power 13. Similarly, the emission. And if you see the runtime, there is a drastic reduction in the runtime, that is 0.00076. You can see it's a 92% runtime reduction with only only 6.22% in the profit gap. Similarly, with only 1.57 emission gap. We can see there is hardly change in profit emission. That is the near optimal solution we were able to achieve with the drastic reduction in runtime and also drastic reduction in number of variables. And this ablation study, if you compare trade-off between accuracy versus efficiency, here on the first figure, on the left side figure, we can see the number of clusters versus the gap percentage, both in profit and emission. The blue line shows the percentage gap of profit. The orange line is emission gap between the original LP and between the original problem and reduced or clustered problem. Similarly, the number of clusters versus runtime. As the number of clusters are getting increased, of course, the runtime will increase. Similarly, profit versus emission, the number of clusters versus profit. Similarly, the number of clusters versus emission. This dotted lines is the original problem profit. Similarly, here this dotted line is the emission on the original LP. And on the cluster, as the number of clusters increases, you can see it's almost trying to reach this original LP or original problem. Similarly, as the number of clusters increases, the emission gap is very less. It's almost reaching this. So both profit and emission values progressively approach the original LP solution as the number of clusters increases. The key findings of our approach is we are able to reduce the problem size from 3,784 to 925 variables. It says in terms of percentage, it's 99.34%. And similarly, the runtime, we are able to reduce by 92%. And hardly the deviation is 6.85 some percentage in terms of in profit gap, whereas emission gap is less than 2%. So feature-aware clustering preserves both optimization relevant structure, and the cluster count provides a controllable accuracy efficiency trade-off. How does it impact in the business? Of course, it enables scalable supply chain optimization. We are trying to reduce the computational cost for large transportation networks, and it supports sustainable decision making and provides near optimal solutions with significantly lower runtime. It can be applicable to logistic, transportation, and green supply chain planning. Coming to the conclusion, we have proposed a feature-aware clustering framework which tried to reduce optimization complexity and also preserving both economic and environmental objectives. And we are able to achieve the near optimal solutions very efficiently. And the most important thing, we are reducing our problem size with almost with 99.5%. In the future work, we are trying to apply this on dynamic supply chains and try with different alternative clustering methods. Thank you. If you are having any questions, I'm free to
Can
answer.
you mention some of the variables you are
Which
considering?
variables, ma'am? Here, my parameters are only the number of clusters.
Number of clusters. So your cluster output will be based on variables value only, right?
Sorry, ma'am.
You are
So
considering
my decision variables in any LP is my Xij. Xij are the decision variables. If you see the original problem,
right, after pre-processing, you are considering only 25 variables.
yes.
I'm asking about that 25 variables. What are you considering?
The 25 is based on clustering, ma'am. How it is, let's say, if I show this
Variables
example.
means they are the parameters, right? It is not clustering.
No, parameters is number of clusters here. The decision variables of LP problem are Xij. Like from supply 1 to destination 1, how much shipment I should carry? How many units from shipment 1 to demand J? So let's suppose, is my screen visible?
Yeah.
If you are taking this vector FS1, this is only from supplier 1.
So
From
you are
supplier
considering
1,
from 25 suppliers.
25 suppliers after clustering. So that may vary. When I'm tuning my clusters, number of clusters, the best which I got is
what
5
does
suppliers and
each
5.
Value define here?
Yes. So here, let's suppose this first 4 are cost. From supplier 1 to demand 1. Similarly, it can be demand J. For example, I'm taking if supplier 1 to 4 demands or 4 destinations I'm transporting from some units, what is the cost associated? This is to demand 1, 12 units of cost, to demand 2, 15 units of cost to transport, and similarly 8 and 10. And the next 4 is emission. When I am transporting this 12 units from supplier 1 to demand 1 or demand J, the carbon emission is 5 units.
Okay. Okay, thank you.
Thank you.
So thank you so much, ma'am. It was a great presentation. To now, we are come to the ending. So now I sincerely thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough, and on behalf of our team, thank you for the support during this virtual conference, and we will be happy to have you in the next session in 2027. And all the presenters, I want to notify them that they would be getting their digital certificates through email within the 2 working days. And the publication will be within 7 to 8 months. And I hope you kindly cooperate with the team. So I also want to thank Professor Mohammad Firoz Mrida sir and Professor Uma Maheshwari sir for chairing this session. And these are the token of appreciation to the chair of behalf of our TIBS 2026 and Global Knowledge Research Foundation and partners. So I would request ma'am to have a few remarks about this conference session. Ma'am, would you like to?
Yes, ma'am. Actually, the papers that has been presented in this particular session are from different domains. It is really knowledgeable. It gave me several insights across various domains also. So the way they are presenting the paper was also very good. They clearly mentioned their statements in a listenable and audible manner. So I totally find this particular session is totally fruitful only. Thank you, ma'am.
Thank you so much, ma'am, for your valuable presence. And now I kindly request all of you to switch on the cameras for a quick snapshot for this virtual conference. Please, everyone can turn on their. Thank you so much. I have took the screenshots. It was great having you in this virtual session. You all can leave the meeting. Thank you so much.